Hello, this is A-level mathematics with Mr. Hayo. Now, we have started a series on this topic called differential equation. And today we want to look at separation variables. In actual fact, we have about 6 methods of solving differential equations. Let me quickly give us methods of solving differential equations. We have what we call separation variable. Separation variable. We have what we call homogeneous equation. Homogeneous equations. We have exact equations. We have linear equations. We have the Bernoulli. We have Bernoulli equations. And lastly, we are going to look at second order differential equations. So these are the general methods of solving differential equations. Okay, but today we are starting with separation variable. Now, so when you are given any question on differential equation to solve, you have to examine the question in order to know which of the methods is suitable. So we are going to start with questions that can be solved using separation variable. So this is a question. Now, how do you know that you can use separation variable from the word separation variable? Now, when you look at the question, you will rearrange the question in such a way that all the dy will be on one side with y, and all your dx will be on the other side with x. If you can rearrange the equation in such a way that all the y variables and dy are on one, they can fall on one side, and all your x variables and dx can also be on the other side, then this method can be applicable. Alright, so let's try this question. The first thing we're going to do is to do cross multiplication. So that cross multiply, we have y into 1 plus x cubic is equal to x squared dx. Okay? Y into 1 plus x cubic. Okay, that is dy. We have dy. We have dy is equal to x squared dx. And the next thing, this 1 plus x cubic, this is in bracket, they are together. I will take it to go and meet this one. So I will have y dy is equal to x squared over 1 plus x cubic dx. So you can now see that y and dy, they are on one side, x and dx are on the other side. So I can use, that means I have separated the variables. So once you can get this, then the next step is you integrate both sides. Okay, that will be integration of y dy is equal to integration of x squared over 1 plus x cubic dx. Okay, so what's the next step? We'll now go and integrate, okay, using the general method of integration. Okay, now if I integrate y dy, I'm going to add 1 to the power and divide by the answer. So it's going to give me y squared over 2. Now let's inspect this one. For me to integrate this function, there are methods of doing integration. We have integration by substitution, we have integration by parts, we have integration by partial fraction. This is 1 plus x cubic. Okay, if I want to use integration by substitution, I will check the denominator. If I find the differentiation, the answer I get, if it's a factor of the numerator, then integration by substitution can work. So let me try to integrate x squared over 1 plus x cubic dx. I'm going to do let u be 1 plus x cubic. Okay, so now I'm going to find the u dx now. The u dx, what will you give me? If I differentiate 1 is a constant, that will give me 0. If I differentiate x cubic, I'm going to have I will bring the 3, will come to the back, then I will minus 1 from the power. That will give me 3x squared. And the next thing I will do is to make this dx the subject of the formula here. So here, my dx will give me du over 3x. What's the next thing? I will go and substitute this one to replace dx here. So this equation will become integral x squared over 1 plus x cubic, that is your u. Then times dx is now du over 3x. Du over 3x squared. So what happens? So what we have done, x squared cancel x squared. So I'm going to have 1 over 3 integral u du. And if I integrate 1 over 3, I'm going to have u squared over 2. I'm going to have, that's 1 over 3 u squared over 2. Okay? sorry, that's a mistake. It's a mistake. This is 1 over u, not u. So this will be 1 over 3 integration of 1 over u du. Now, if we integrate 1 over u, it's going to give us ln u. Ln. So this is 1 over 3 ln u plus c. Then you now return back to u. Your u is 1 plus s cubic. So that means the answer is now 1 over 3 ln 1 plus s cubic plus c. Alright? So I've gotten this one to be 1 over 3 ln 1 over s cubic plus c. So the final answer, okay? So this is what we call integration by substitution. Now, so the final answer now from here, I need to claim this place. So the final answer, if I integrate y, I'm going to have y squared over 2. Okay, is equal to integration of this one. What I got here, the answer is 1 over 3 ln 1 plus x cubic, then plus c. All right. So you can see now this is if I can now say y squared is equal to 2 over 3 ln 1 plus x cubic plus c. So this is the final answer of this question, the solution of this differential equation. So how do you apply separation variable? Just you examine the question. You check if you can separate the y variables from the x variables. After that, then you now integrate both sides and you get your answer. So I hope that is clear. Okay, I'll just do one more example on this. One more example. Solve dy dx is equal to exponent raised to x minus y. It's another question. We want to solve it. Solve dy dx is equal to exponent raised to power x minus y. So what the first thing we do, since I want to separate the variables, I will go and apply lots of indices here. I will turn this minus to division. So I will have dy dx is equal to exponent raised to x over exponent raised to y. Okay, so the next thing is to do cross multiplication. We're going to have exponent raised to power y dy is equal to exponent raised to power x dx. Alright, so you can see that the y variable is now separated from the x variable. So the next step is integrate both sides. Integrate both sides. Integrate both sides. So I'm going to have integration of exponent y dy is equal to integration of exponent x dx. Now, anytime you integrate exponent, what you get back is exponent. So I'm going to have exponent y is equal to exponent x plus constant, and this will be the final answer. So this is the final answer of the question. So this way I'm going to stop for today's series. This is separation variable. Join me for the next class. Thank you.